Okay, so this is paper 2, variant 2, October, November 2020. So the question 1 is, complete the table 1.1 by putting a tick in the appropriate column to indicate whether the listed quantities are scalar or vector. So the first one, acceleration, it's a vector because it has fixed direction. Then density, no fixed direction, it's a scalar. Temperature, scalar, and the momentum is a vector. Now the B part is a toy train moves along the straight section of the track. Figure shows a variation with time t of the distance t moved by the train. Describe qualitatively the motion of the train between 0 and time 1 second. Look, the gradient of this graph is equal to speed. So between 0 and 1, the gradient of the graph is decreasing. So we will write gradient is decreasing. Hence, speed of train decreasing. So the gradient is decreasing between 0 to 1, and the gradient is the speed. Hence, the speed of the toy train is decreasing. Next, determine the speed of the train at time 2 seconds. So at 2 seconds, look, this is the point, and it's a straight line from this point to this point. So the gradient of this straight line will give you the speed. So the gradient is equal to change in the y-axis divided by change in the x-axis. So the change in the y-axis is from 1.5 to 3. So 3 minus 1.5, sorry, this is 0.2 y-axis and this 6, not the x-axis, okay? So the final is 0.6 and this point is the 0.2. So 0.6 minus 0.2 divided by the difference in the x-axis is 3 minus 1.5. So 0.4 divided by 1.5. So after the calculation, the answer is coming 0.24 meter per second. So here we have derived 0.24 meter per second. Next, the straight section of the track in B is the part of the loop of the track shown in the figure 1.2. So this is the track. It's a closed loop. The train completes exactly 1 lap of the loop. State and explain the average velocity of the train over one complete tap. Look, average velocity is equal to total displacement divided by time. So in one complete loop, displacement x is 0. Hence, average velocity is also 0 meter per second. So this is the question number 1. Okay, now move to next question. Question number 2. Question is, a cylinder is suspended from the end of the string. The cylinder is stationary in water with the axis of the cylinder vertical, mean it's straight down. It's not leaning. The cylinder has a weight of 0.84 and the height h and the cross-sectional area of the diameter 0.031 meter. The density of the water is 1 in 10 power 3. The difference between the pressure on the top and the bottom face cylinder is 520. Calculate the height. Look, the pressure difference between the top and the bottom is given. We have to calculate the height. So simply the difference in the pressure is equal to rho g h. So the pressure difference is 520. Density is given 1 into 10 power 3, mean 1000, G value 9.81. And this height is required. So 520 divided by this, and the height will be 0.053 meter. This is the height. Next part is show that the upthrust acting on the cylinder is 0.39 Newton. Upthrust is due to the pressure difference. So we will write here upthrust U is equal to pressure difference multiplied by area. So it can be written as rho GH into area. So this pressure difference is equal to 520 multiplied by area. Area, either write pi r square or write pi by 4 diameter square. If the diameter is given, then it will be pi by 4, and diameter square mean 0.03 whole square. Now calculate this. So 520 multiplied by pi divided by this and multiply by square of this. You will get the same answer, 0.39. Next is calculate the tension in the string. Look, weight of the cylinder is acting down and upthrust acting up. So the difference of these two forces is the tension in the string. So we will write here, the tension is equal to weight minus upthrust. So the weight is given 0.84 and the upthrust calculated 0.39. So the tension answer will be 0.45 Newton. The difference of two forces up and down is the tension. Now the B part is the string is now used to move the cylinder vertically upward through the water. The variation with the time t of the velocity v of the cylinder is shown in the figure. Use the figure, determine the acceleration of the cylinder at time 2 second. Look, this is 2 second point. So straight line, we have to calculate the gradient of the line. So gradient of the line are change in velocity divided by time. So the velocity change is 10 for this point and 0. So 10 divided by 10 minus 0 divided by, and the time difference is 2. So answer is equal to, sorry, this the difference is 2.5. The time is 2.5 for this 10. So answer is coming 4 centimeter per second square, but we have to write this in meter. So we can write 4.0 into 10 power minus 2 meters per second square. Now the next part is the top face of the cylinder is at the depth of 0.32 meter below the surface of the water at the time 0. To determine the depth of the top face below the surface of the water at time 4 seconds. So first we will calculate how much distance is covered upward in 4 seconds, mean area of this triangle. So the distance covered up is the area, 1 by 2 base into height. So 1 by 2, the base of this whole triangle is 4, and the height of this triangle is 10. 2 ones are 2s are, it is 20 centimeter, mean 0.20 meter. It moves up, and initially the depth was 0.32. So the new depth will be 0.32 minus upward distance. So the answer will be 0.12 meter. And the C part is the cylinder in B is released from the string at time 4 seconds. The cylinder falls from the rest vertically downward to the water. Assume that the upthrust acting on the water remains constant as it falls. State the name of the force that acts on the cylinder when it's moving and does not act on the cylinder when it's stationary. So The cylinder is moving in the water, in the liquid, and there is a resistance from the liquid. So that resistance is called viscous force of the fluid. Which is also called the drag force of the fluid. It's like the air resistance. State and explain the variation, if any, of the acceleration of the cylinder as it falls downward through the water. So when it accelerates, its speed, its velocity increases. Due to this increase in the velocity, viscous force also increases. The resultant force decreases. Hence, the acceleration decreases. Look, if this is the object, this is the constant forward force, but when the air resistance increases, resultant force decreases. When resultant force decreases, resultant force is equal to ma, and acceleration also decreases. So this is question number 2. Okay, now move to next question. Question number 3. So the question is, a spring is fixed at one end and is compressed by the spring, applying the force of the other end. The variation of the force F acting on the spring when it is compressed, X, is shown in the figure. It means this question is related to deformation in solids. A compression of the 0.045 meter is produced when F1 act on the spring. The spring has a constant 800 Newton. So determine F1. According to Hooke's law, F is equal to Kx. This F is F1, K is 800, and X extension is 0.45. So when both are multiplied, the answer is 36 Newton. So this is the F1 force. Use the figure to show that for the compression of 0.045 meter, the elastic potential energy, look, the energy stored in the spring is the area under the graph. So energy is equal to, either calculate the area, or we can write 1 by 2 kx square, or 1 by 2 fx. It's up to you. So 1 by 2, the k is 800, and the extension is 0.05 square. So you will get the same answer, 0.81 joule. Next is, a child's toy uses a spring to launch the ball of the mass 0.02 kilogram vertically into the air. The ball is initially held against one end of the spring, which has a compression of 0.045 meter. The spring is then released to launch the ball. The kinetic energy of the ball as it leaves the spring is 0.72. The toy converts the elastic potential energy into kinetic energy of the ball. Use the information to calculate the percentage efficiency of conversion. Look, efficiency is equal to output energy divided by input energy. But here the percentage, then we will write 100. So the output energy is 0.72. Input is 0.81 multiplied by 100. So the answer will be 72 divided by 0.81. So it is 89%. This is the conversion percentage. Next, determine the initial momentum of the ball as it leaves the toy. So initial momentum is required. Look, kinetic energy is equal to momentum square over 2m, or we can write momentum is equal to 2m kinetic energy under root. So 2 multiplied by the mass is 0.02. So we will write here 0.02. Kinetic energy is 0.72 and then under root. So after the multiplication, 0.04 multiplied by 0.72, the momentum is coming 0.17 Newton second. Or you can apply kinetic energy is equal to half mv square. From this equation, calculate the speed, and then momentum is equal to mass into velocity, or use directly this formula. It's up to you. Next, the C part is the ball in B leaves the toy at the point A and moves vertically upward to the air. The point B is the point of the ball when it is at the maximum height. The gravitational potential energy of the ball increases by 0.6 joule as it moves from A to B. Calculate H. Definitely, we will write the formula. Gravitational potential energy is equal to mgh. So gravitational potential energy is equal to 0.60, mass is 0.02, G 9.81 into H. So 0.6 divided by 0.02 divided by 9.81, and the height will be 3.1 meter. Next, determine the average force due to air resistance acting on the ball for its movement from A to B. Look, at A, the energy is 0.72. But at the top here, the B, the energy left only 0.60 joule. It means the loss of energy dissipated, is equal to 0.72 minus 0.62. This is used to overcome the friction, to overcome the resistive forces. So work is done against the friction, against the air resistance. So the work is equal to F into D. So 0.72 minus 0.60. This is not 62, this is 60. So the answer is 0.12, the difference. So this is the work done, force required, and the distance covered is 3.1. Hence, F is equal to 0.12 divided by 3.1. So the average force is 0.039. Now, the next part is when there's an air resistance, the ball takes t to move from A to B. State and explain whether the time taken for the ball to move from A to its maximum height will be more, less than, or equal to t if there is no air resistance. Look, if the ball is moving up, in the absence of the air, the only force acting down is its weight. But when the same ball is moving up in the presence of the air, then one force acting down is weight and other is air resistance. So we can write in the absence of the air resistance, the resultant force is small, only the weight. When the resultant force is small, the retardation is also small, and the retardation is equal to the change in velocity divided by time. So retardation and time both are inversely proportional. Hence, the time taken will be large. So in the absence of the air, the only force which opposing the motion is the weight. So less force, less retardation. So it takes longer to stop. Hence, the time taken will be large as compared to the time in the presence of the air. Okay, in this question, a rigid plank is used to make the ramp between the two different horizontal levels as shown in the figure. The plank A at one end of the plank rests on the lower level of the ground. A force acts on and is perpendicular to the plank at the point B. The plank is held in the equilibrium by the rope and it is connected with the point D. The plank has a weight that may be considered to act at the center of the gravity. The rope is perpendicular to the plank and has tension T. The plank is at the angle of 38 degrees to the vertical. Show that the component of the weight that is perpendicular to the plaque is 59. So look, so when weight is resolved into components, so this is its x component, mean the line adjacent to the angle is the x component, and this is the y component. So we have to calculate the perpendicular y component. So wy is equal to w sine theta. So we have to calculate this 96 sine of 38 degree. You will get this answer. By taking the moment about the end A, calculate the tension. Look, this is the pivot. Now this Wx is passing through the pivot, so it has no turning effect. This Wy has turning effect. This T has turning effect. This 45 has turning effect. So clockwise, just 145. Anti-clockwise, there are two forces. So we can write F1 D1 is equal to F2 D2 plus F3 D3. So look, this is 45 and its total distance will be 1.5, 0.3, and then this is 1.8. Okay, so F1 D1 is equal to F2 D2, F3 D3. So F1 is 45, it's a clockwise, and its distance from the pivot 1.1 plus 0.3 plus 1.5. So its total become 2.9. Then F2 anti-clockwise is the tension T which is required, and its distance from the pivot will be 0.3 and 1.5, 1.8. And the second force is Wy, which is 59, and its distance from the pivot will be 1.5. Now multiply these two, multiply with these two, difference of these two divided by 1.8. Let me calculate. So this minus this one divided by 1.8. So the answer of the tension is coming 23 Newton. So we have to write this calculation over here. So this is question number 4. Now move to next question. The question is, the microwave with the same wavelength and amplitude are emitted in phase from the sources X and Y as shown. The microwave detector is moved along the path of the parallel to the line joining X and Y. An interference pattern is detected as the central intensity maxima is located at A. So this is 0 lambda, path difference. And at adjacent intensity minima is point B. So this will be 0.5 lambda dark spot. The microwave has a wavelength of 0.04 lambda. Calculate in the frequency in gigahertz of the microwave. So we will write V is equal to F lambda. F is equal to V divided by lambda. Microwave travels with the speed of light, 3 to 10 power 8, and the wavelength is 0.040. So this frequency is coming 7.5 into 10 power 9. So just 10 to 9 is giga. So we will write here 7.5. Next, for the wave arriving at B, determine the path difference. So path difference for the dark spot here is 0.5. So we will write the path difference is equal to 0.5 lambda. So 0.5 multiplied by lambda 0.40. So it will be 0.020. Then the phase difference. Now look, the phase difference will be 180 because 1 lambda is equal to 360 degree and the 0.5 lambda will be equal to 180 degree. The next, the amplitude of the wave from the sources are changed. This causes the change in the amplitude of the wave arriving at the point A. At this point, the amplitude of the wave arriving from the source B is doubled, and the amplitude of the wave arriving from the source Y is also doubled. Describe the effect, if any, on the intensity of the central maxima. Look, intensity is directly proportional to amplitude square, mean when amplitude becomes double, then intensity increases by factor 4. So the intensity increases by 4 times more intensity if the amplitude becomes double. Next, the D part is describe the effect, if any, on the position of the central intensity maxima and the adjacent intensity minima due to the following separate changes. The separation of the X and Y are increased. Separation of X and Y. So what is X and Y? Look, X and Y is the slit separation. So we will write the expression X is equal to lambda D over A. When this A increases, this separation decreases, hence minima and the maxima will get close to each other. So this gap is increasing, slit separation is increasing and fringe spacing decreasing. So maxima and minima will be more close to each other after this change. The phase difference between the microwave emitted at source X and Y changes to 180. So initially, both were in phase, mean they were like this. But now they are out of phase. So this is crest, this is trough. So definitely due to this path difference, due to this phase difference, minima and maxima will exchange. So we will write here, the maximum becomes minima and so on. And the minima become maxima, mean maxima and minima will exchange their positions. Now move to this question number 6. A network of the 3 resistors of the resistance R1, R2, R3 is shown. All are connected parallel. The individual current in the resistors I1, I2, I3, the total current in the combination of the resistor is I, and the potential difference across the combination is V. Show that the combined resistance is this. Look, according to the Kirchhoff first law, sum of the currents entering the junction is equal to sum of the currents leaving the junction. This is a junction, I entering, I1, I2, I3 leaving, and according to Ohm's law, V is equal to IR, I is equal to V by R, so V divided by R. In parallel, the voltage remains same, so V over R1 plus V over R2 plus V over R3. Now V over R, take V common from right side, so 1 over R1, 1 over R2, 1 over R3. When we cancel, then you will get this relation. Now the next part is a battery of the EMF 8 volt and internal resistance R is connected to 3 resistors X, Y, and Z. 8 volt internal resistance X and Z, and this Y, and the current 0.45, here 0.49. Now the question is, the resistance Y has a resistance of 16. The current in X is 0.49 and in Y, is 0.45. Calculate the current. Look, I current from the battery is I1 plus I2. So 0.49 plus 0.45. So the current will be 0.94. Now we have to calculate the internal resistance. 2 marks. Look, here the total current flowing through this circuit is 0.94. So 0.94 current ampere is passing through the resistor. And here, what is the voltage? V is equal to IR. So V is equal to 0.45 multiplied by 16. So this is the voltage, which is across the Y. Now, what is the voltage lost? So the voltage which is lost across the internal resistance will be 8 minus 0.45 into 16. And this is lost across the internal resistance. So calculate this. 0.45 times 16, this is 7.2. So 8 minus 7.2 mean 0.8 volt is lost across internal resistance. Hence, V is equal to I into R. So the voltage loss is 0.8. The current passing is 0.94 and the resistance internal required. So 0.84 divided by 0.94. So the internal resistance is 0.85 ohm. So we will write here 0.85 and all calculation over here. Now the next, resistors X and Y in the figure 6.2 are made from the wire of the same material, same cross-sectional area. The average drift velocity of the free electron in X is 2.1 and 10 power minus 4. Calculate the average velocity of the free electrons in Y. So this is the value for the X current. Now look, drift velocity, I is equal to eta QAV, mean drift velocity is equal to I divided by eta QA. Same material, same number density of the free electron, same charge of the electron, and same cross-sectional area. So the drift velocity directly proportional to current. So hence we can write drift velocity of Y divided by drift velocity of X, current of Y divided by current of X. So Vy is equal to the current in Y. Look, the current in Y is 0.45 divided by current in X. The current in X is 0.49 and multiply by velocity of the X is given 2.1, 10 power minus 4. So after the calculation, the answer is 1.9 into 10 power minus 4. This is the drift velocity in resistor Y. Resistor Z in the figure 6.2 is replaced by the new resistor of the small resistance. State and explain the effect, if any, on the terminal potential difference of the battery. Mean terminal potential TP is equal to EMF minus loss potential across the internal resistor. Look, when resistance decreases, total resistance of the circuit also decreases. Hence, current in the circuit increases. When the large current passes through this internal resistance, loss potential increases, so the terminal potential decreases. So look, I repeat, resistance total decreases, current in the circuit increases. When the large current passes through the fixed internal resistance, lost voltage across it is increased. So the EMF is constant. So when more voltage is lost, less is delivered out by the cell as a terminal potential. Hence, the terminal potential decreases. Now, the next question is, state the similarity and the differences between up quark and up anti-quark. So what's the similarity? They have same mass, equal mass. And what's the difference? They have opposite charges. One has positive and other has negative. Next, the figure 7.1 shows an electron in an electric field in a vacuum. At an instant when the electron is stationary, draw an arrow to show the direction of the electric force acting on the stationary electron. Look, field lines are directed towards left. Mean this side is positive, this side is negative. This is negatively charged electron, so definitely it's attracted by the positive plate. So this is the direction of the force on the electron. The electric field causes the electron to move from its initial position. Describe and explain the acceleration of the electron due to the field as shown. As the electron moves through the field, look, as it moves towards right, the gap between the lines decreasing, mean towards right, electric field strength increases. So force directly proportional to electric field strength. Hence, the force experience increases. When force increases, acceleration of the electron also increases. And the next is a stationary alpha particle is now placed in the same electric field at the same initial position that was occupied by the electron. Compare the initial electric force on the alpha particle with the initial electric force that act on the electron. Look, force depends on the charge. Electron has -1e and the alpha has positive 2e. So due to double charge, the force experienced by the alpha will be twice of the force experienced by the electron. So this is the paper.